Hi everyone. Within this tutorial, I would be talking about introduction to survival curve fitting. And for this specific tutorial, I would just be concerned with this specific paper called um, by Hoyle and Henley for improved curve fits to summary of survival data. And it comes along with an Excel template that you can basically use to extrapolate use the extrapolated data from Digitizer app and probably use that to fill in the information within the Excel sheet, which I would just show you in a bit. But there are obviously other techniques which can be used, but I find this to be much better as compared to GOIT, which is the second article here for the reconstruction of survival analysis. And if you really want to look at the details of the sort of differences that are present between both of them, they're very subtle. They're not like a huge difference, but obviously there is a difference in terms of how you set up your survival distributions. The one by GOIT is just based within R, but the Excel one gives you more flexibility to see how uh, number of events are put into the file and how they can be used to estimate the amount of censorships, because obviously when you have survival data, you have a Kaplan Mier data at every single point, which is a non-parametric data available. So we need to use that data to be able to see what were the other events that were happening during that time for a smooth curve fitting, which this sheet does very excellently. And then you can use those to set up a distribution within R and then import your relative parameters that are necessary for your survival curve distribution that you can be using with any sort of economic modeling that you're using. If you're using Excel, you can use time-dependent probabilities. If you're using another software, maybe like FreeAge, then you can use that for there as well. But you obviously have to have some sort of changes to those parameters depending on the software that you're using, and you can easily Google that up in terms of uh, parametric distributions and parameterization of different distributions for different softwares. Uh, so I find this need to be more useful. More it gives me a better smooth fit, but obviously there are differences in every technique that you use, and if you want to validate your technique, you probably should use competing analysis. So the very first step is to be able to download this file, which is mentioned within this article if you search online, and um, from BMC Medical Research Methodology. And this is how the Excel file looks like. So you have different tabs here, and it gives you a very rough introduction on what you should be doing. And then you have other tabs with like telling you how the survival curve should, or the Kaplan-Meier curve should look like, where you import information from the Digitizer app and then put that into Excel. Then you have your amount of number of events and censorship, which I have already filled in. Then you have this R data that is compiled from the information that you would fill in. You have your code that you would use in R. So you basically just have to tweak very little to be able to get your relative distribution. And then you can see actually in terms of visualization, you can see how that would look on in Excel in terms of how your distribution looks like compared to your actual data, which is the Kaplan Meier plots. So it's very easy to follow. So it just says that first of all, you need to fill in your number of risks that are provided within the article or the trial that you're using for your Kaplan Meier plots. And basically what you have to do is you have to make sure at what interval or what time points you have that data available. So preferably it's best if you have it every 3 months or every 3 years, depends on how you do it. I think most of it is based on months. So that can be extrapolated to years when you use a survival distribution. But you should at minimum have intervals that spread across 6 months at least to be able to have a good distribution. So yeah, so if it says that if you have fewer than 25 for the number of for the number at risk, then you should leave the remaining white cells empty. Then read off the times of survival probability from published Kaplan-Meier plots and put the column B and E, and then the formula would automatically calculate the number of people at risk at different time points between those intervals that are not available. And then basically step 2 is to check how if you entered everything correctly, and you save the R sheet, you update the directory by whatever R code you want to use to that, and then you generate your survival curves based on those information that's available. So let's start with first looking at the Digitizer app and how that would be working. And let me just sorry, let me just toggle my screen in a. So for the Digitizer app, we basically have this. I have this article already logged in, so you just need to load up image, which you can just screenshot from one of the articles, and I've already done that in advance, but I'll just show you some of the steps on how that works. So I'm just going to take here. So basically, this is the graph that I've loaded into the Digitizer app, which you can find online. And basically, you load the image, you choose your file where you have stored the specific picture for that survival curve. And once you've loaded, you basically go to Axis, and then you tweak calibration. But the first time you're doing it, will automatically ask you for that. So as you can see, I have X1 here and X2 point here, and they have to be aligned perfectly with Y points. And once you do that, you complete your calibration by making sure the x-axis corresponds to the number of months on the x-axis, and y-axis is basically 0 to 1, which would give us the survival probability. So the next thing you need to do is, this is much easier to do if you do it with the automatic extraction. You take a pen and you highlight this whole area for the curve, and I've already done that for one of the curves, which was blue in the background, and you select the foreground color, which is blue, and you press done. And once you've done that, you go to the logarithm that should be used, which is x with the interpolation, and you want it exactly to be from 0 to 0.75 units for x axis, which is this, because this is what is required for the Excel sheet to have time points on every 0.75 months. And once you do that, you select your y-axis, which are already set to the default numbers. And once you run it, you will have all the specific points, and you can take the data into Excel by looking at the data if that looks okay, looks okay to me. And you download a CSV file and store it somewhere in your computer. And once you've done that, you come back to Excel and you load all those numbers within your survival empirical probability, the ones that you've extrapolated from the Digitizer app. And you also, in addition to that, you also need to make sure that you filled in the number at risk on the specific time point intervals. And this you can find from the information that's available within your Kaplan-Meier plots. And as you can see, I have information available at every month, but I just require it to be on 0, 3, 6, 9, and 12 in other specific months. And if it's not available for a certain month, you can just leave it blank. Or there are other ways which I would probably talk about another time to address those. But if you don't have those available, you can just leave that blank as mentioned in the introduction description within this Excel file for survival distribution. So once you've done that, you can just quickly go and look at the curve fitting within, this is R code here. You would have an R code or R data, and you basically have to save this file, and you have to save that as in a tab text file, which is tab delimited file in a certain folder. You save that. I've already done that. And the next step is to look at this R code, which basically is a step-by-step process. You first load your survival library. The other step is to attach that data by specifying the file name where you've stored that text file. Then you run this certain command in R Studio, and then you have different survival functions to choose from. And I prefer viable, but the common criteria or the standard way of doing is to be able to run a couple of these and check what the AIC criterion suggests on which value would be the lowest. So the survival distribution, which has the lowest AIC value, is most preferable. But in my experience, I just think that the difference is sometimes not so significant, and you can use viable or log logistic. It really depends on which criteria you're using and which parameters you prefer to be applying to your certain IPD, individual patient data. So once you've done that, you've chosen your distribution. You can omit this maybe, but maybe you have to run this code before that, and then you run this certain code for the output of gamma and lambda that are needed for viable. So this is specifically for viable, but if you want to learn other kind of distributions, you can just Google them on the specific formulas that are required, and you can find within R, you can go and find like how the distribution works in R with the specific individual patient data that's available. So, I mean, I'm just going to just show you how this really works, and I'm going to copy, because I put that in another file, which is my Word file. So I'm just going to show you how it works within R. Now I can get those points. So yeah, so this is R Studio, and I just want to run my library first. And I copy this, and I run this first. Once I've loaded the library, I need to attach the data. And for me, I've already set up the commands in advance, so save time. And some error with the command. I have to just quickly see what that is. And maybe I have a space here. So then I already have my data set now. So after that, I'm just going to attach and run the other commands that are mentioned. If you really want to understand what's going, or what these commands mean, actually you can just find out from online libraries. And then basically I just want to run the viable distribution just to show you how that works. And put that in, and I get those time end and time start point. And I will just omit the AIC criteria, because that really depends on which distribution you're applying. And I have to make sure I have number of patients. Once I've done that, I need my intercept and log scale numbers, but I also need my other lambdas and gamma for my viable. So I find that, and once I have that, I just want to show lambda, or you can just summary. And because I think my distribution was saved within the model, so I'm just going to look at that first. And here I have my scale, intercept and log scale, which I'm going to be using. And I take these two values back to Excel, where I put them right here next to the intercept and log scale. And I'm just going to import that from here. This is 2 point. Yeah, so that goes there. And then the log scale value, which is this, is going to go here. And now I can run the other parts of the analysis, which is available within the code, but I would not go there because it's just a specific command that you have to run, and then you have to import these two values for your Kleski or the probabilistic values of your survival curve to give you that confidence interval around the uncertainty. And I'm just going to look at my Kaplan-Meier plots. So, I mean, right now it doesn't look so well, but let me just check what I've done wrong. So, okay, maybe I have the wrong file here. So I'm just going to yeah, so I had the wrong file. I'm sorry about that. So once you put that in, you see that this is actually your curve fit, which is basically the green line here. And that resonates with your Kaplan-Meier plot, which is the original plot, and seems like the distribution seems fit to be fitting quite reasonably okay visually. And then you can be using these for to estimate or use within other softwares that you want to, like there's certain parameterization that you could be using within FreeH, but then you just use the survival curve function to estimate the viable distribution at every time point. So, and this is the formula that's already set up here. You can also find that online for viable, and then you would have the estimated viable deterministic values. And for PSA, you basically need to fill in this Kleski, lambda, and gamma that will again be very simple from the R code that's available within the file. Just run that and import those here, and then you would have your simulated values for probabilistic simulated analysis. So yeah, thank you very much for joining in me for this session. There's something additional to this which I would be sharing at some point, which is how if you're doing a manual sort of a point calibration for some graphs and the automatic calibration doesn't work on the Digitizer app, you can always kind of find a way to find an amount of number of censorships and events by reverse engineering your way through events and censorship based on these formula that's available within the sheet as well. So I hope that was useful, and thank you so much for joining in. And please write a comment if you have any other questions, and I would drop down my email within the description. And thank you so much.